Hello student, today we are going to discuss about the other part of our recipe. Okay, so our first topic is your Ohm's law here. So you should know here what does the Ohm's law says here. The Ohm's law says that the potential difference across two ends of a conductor. Okay, so there is a conductor here, two ends, we make it A and B here. So the potential difference in a conductor is going to be directly dependent on the amount of current flowing through it, means flowing to the conductor. It means that the potential difference is going to increase when the current is increased, and potential difference is going to decrease when the current is decreased. So mathematically, if we want to write the Ohm's law, what are we going to get here? Let V be our potential difference, I be our current. Then we can say here that V is proportional to whom? I. It is V is equal to IR. Okay. This very, to remove the proportional sign, I put this very constant here R here. Where R is the proportionality constant and it is known as the resistance here. So now what is resistance here? Resistance is that property of a conductor which resists the flow of current. Resist the flow of current means you can know as which controls the flow of current. That means in one conductor or in one appliance, how much amount of current should flow. Okay, it is going to be determined by the resistance here. So you know resistance is the property which is going to resist, that is control the flow of current in a conductor or any type of appliance here. So SI unit of resistance is your ohm here. Okay, so sometime we might discuss about what is 1 ohm. Okay, and definition comes in the exam, define 1 ohm. So we know that ohm is the unit of resistance here. So what is the formula we got from here? Formula is your V is equal to IR, that is R is equal to V by I here. So if you want it to be 1 ohm, that means this potential difference should be 1 volt and the current should be 1 ampere. That means the resistance of a conductor or any other appliance is said to be 1 ohm if 1 volt of potential difference is applied if for a flowing of how many ampere of current? 1 ampere of current. That means in a conductor, if the potential difference is 1 volt and the current flowing through it is 1 ampere, then the resistance will be considered, or the resistance will be said to be 1 ohm here. Now next topic, okay, let us discuss about the factors on which the resistance depends here. Okay, so resistance depends on three kinds of factors. Okay, resistance depends on three kinds of factors. Number one is resistance of a conductor is directly proportional to the length of the wire. That means जितना बड़ा लेंथ होगा उतना ही ज्यादा तुम्हारा रेजिस्टेंस होगा, जितना छोटा तुम्हारा लेंथ होगा उतना ही कम तुम्हारा रेजिस्टेंस होगा. ठीक है, मींस if the length will increase, resistance is also going to increase. If the length is going to decrease, the resistance is also going to decrease here. Okay, number one. Number two is your resistance is inversely proportional to the area of cross section. When talking about area of cross section, we are talking about the thickness of the conductor. Okay, you can see in your home there are wires. Some wires are there which are very thin. Some of them are very fat here. Okay, so that very thickness is nothing but the area of the conductor here. So रेजिस्टेंस इज इनवर्सली प्रोपोर्शनल का मतलब क्या होगा? अगर एरिया बढ़ेगा तो रेजिस्टेंस कमेगा और एरिया कमेगा तो रेजिस्टेंस बढ़ेगा. The third one is your what type of material is used. Okay, now we know that for making our wire we basically use copper. Okay, but copper is not the best conductor. Okay, more than copper, you can say like your gold, silver are more better conductor. Okay, so that means it depends on what type of conductor you are using. So that's why we say the third point is the resistance of a conductor. It depends on the type of material used for making the conductor here. So if you take it as equation 1, equation 2, from 1 to if you compare, you're going to get R is proportional to L by A. To remove the proportional sign, I brought this symbol. This is nothing but rho. Okay, the symbol is pronounced as rho, and this is known as the resistivity of the conductor. Okay, or resistivity of the material here. What the formula you got here? R is equal to rho into L by A here. Now we got our new term here. The new term is what your rho. So we need to find out the SI unit of rho here now. You can come here, SI unit of resistivity, that is your rho here. What we have here? What is the formula we give? We got R equal to rho into L by A. So if I cross multiply, I'll get rho into L is equal to R into A. That is rho is equal to R into A by L here. R means resistance. We already know that the unit of resistance is what? Ohm. So I wrote here ohm. Area of any type of quantity, it is meter square. Okay, SI unit. So I wrote a meter square. This is length. Length is the meter. Meter got cancelled. What is left? Ohm meter. So SI unit of resistivity is ohm meter here. Okay. So now we might be thinking about what is the meaning of resistivity. Okay. So we will not go to the proper definition of resistivity. Just to make you understand, you should know that resistivity value Okay, if you know the resistivity value of a conductor, okay, then you can say that either the conductor is a either the material is a good conductor or a poor conductor. For example, if I give you two values, one value is 2 into 10 to the power minus 8, other one is 2 into 10 to the power minus 4 ohm meter. And if I ask you, out of these two material, which material have a or which material is a better conductor of electricity, okay, so you just see which value is bigger here and which value is smaller here. We can see that minus 8 is more bigger or minus 4 is more bigger. Obviously minus 4 is more bigger than minus 8. Minus 8 is more smaller than minus 4. That means this value is more smaller than this value. That means this conductor A, make it A and B. That means A is a more better conductor than B, okay. That does not mean that B is a bad conductor, okay, but if you compare the condition of these two material A and B, we can say that A is a more better conductor compared to your B here. So रेसिस्टिविटी वैल्यू से हमें क्या पता चलेगा? हमें ये पता चलेगा कि कोई भी मटेरियल जो है वो अच्छा कंडक्टर है या बुरा कंडक्टर है. अगर रेसिस्टिविटी वैल्यू बहुत ज्यादा होता है तो वो बहुत खराब कंडक्टर होगा. अगर रेसिस्टिविटी वैल्यू बहुत छोटा होता है या बहुत कम होता है तो वो अच्छा कंडक्टर होगा. ओके. So now next we are going to discuss some of the numericals from our exercises. Okay. So we are going to discuss about the next question that is from your book only, the example from your book. They say here a wire of given material having length how much? L. Our length is L and area of cross section is A here. Has the resistance of how much here? 4 ohm. So this is our for the fast wire. Okay. So now what I wrote here for fast wire. We know formula is resistance R is equal to rho into L by A. So they say length is L, so I have no changes here. Area is A, so no changes here. But what they say, the resistance is how much here? 4 ohm. So in place of R, what did they write? 4 ohm equal to rho into L by A, equation number 1 here. Now go to the second wire. They say that what should be the resistance? So that means my resistance is question mark here. Of another wire of what material? Same material. If they would have changed the material, if they would say the different material, then you cannot take the rho in both the cases. You can see here also I have taken rho and here also I have taken here rho. Why I have taken rho? Because the material is same. If the material is same, the resistivity value is also going to be same. So no need to change the resistivity value here. They said having length how much here? L by 2. So there is new length, so I have taken L dash. L dash equal to how much I have taken here? L by 2. And area of cross section is how much here? 2A. That is A dash is equal to how much here? 2A here. So I wrote the formula. Our formula is what? R dash is equal to rho into L by A. But now here length is how much? L dash. And area is how much here? A dash. So now R dash means R dash, rho then rho, L dash. Okay. L dash is how much here? L by 2. A dash is how much here? 2A. This 2 will come downside. That means 2 2 will become 4. Rho then rho, L then L, and A then A. This 4 I have taken outside. What I got? Rho into L by A here. That means R dash equal to 1 by 4 rho into L by A. You can see here rho into L by A is equal to how much here? 4 ohm. That is, I will in place of rho into L by A, what can I write? I can write 4. I will written here from what? From equation number 1 here. This cancel how much here? 1 ohm. That means they are asking what will be the resistance. You can say that the resistance of the another wire is nothing but 1 ohm here. Okay. So our next question is from your page number 221, question number 6. Okay, very important question. This question came in 2019 also. So not the same question, but the question which is in your example. Okay, so who knows? Okay, next time you might get this question also. So now in this question, if you read, they say here a copper wire of diameter. Diameter is how much? 0.5 mm. We know that our diameter is not related to any formula. We need radius. So I need to find a radius here. Radius R is equal to how much? 0.5 divided by 2 mm. This is millimeter. I need to write in terms of meter. You should know that 1 millimeter is equal to 10 to the power minus 3 meter. That is, I remove my millimeter with 10 to the minus 3 meter here. Then they say in the question, and resistivity. Resistivity means it is raw value. Raw value is how much here? 1.6 into 10 to the power minus 8 ohm meter. They said that what will be the length of the wire to make the resistance to be 10 ohm. They are telling us to find the length of the wire is L value to make our resistance is how many ohm? 10 ohm here. So now we know the formula. The formula is what? R equal to rho into L by A. That means you need the value for area of cross section. So what I have written here now? Area of cross section. Remember, this is a wire. Wire is always in the shape of cylinder. Okay. Cylinder means you can say that we don't need what is the length of the wire. We are going to find it out. we need this very area of cross section. This area of cross section is nothing but the circular. Circular means what? Circle. Okay. That means we need to find the area of circle here. Area of cross section means area of circle here. The area of cross section is equal to how much? Pi r square. 22 by 7 into r value already we have got 0.5 by 2 into 10 to the power minus 3 meter whole square. I broke it out. This is 0.5 2 times 0.5 into 0.5 10 to the power minus 3 into 2 means 10 to the minus 6 divided by 7 then 7 2 to that will become your 4 here. So now we got all the values. You can find out your length here. Okay, so what is the formula? We know r is equal to rho into L by A, that is L is equal to r into A by rho. Okay, L value, R value is 10 ohm, A value already you can put from here 22 into 0.5 into 0.5 into 10 to the minus 6. Rho value we have here 1.6 into 10 to the minus 8, and you can see we have 7 into 4. This 7 into 4 will come downside here. Then I cancel my 4. 2 to the 4, 2 5 the 10, 2 on the 2, 2 11 the 22. Okay. Then I wrote 10 into 12 into this 0.5, then 0.5, 0.5, 0.5, this is minus 6, this is downside, isn't it? Base is 10, so I took it upside, minus will become plus, it will become 10 to the power 8 here. After cancelling, I got 5 into 11 into 5 into 5 into 10 to the power minus 6 plus 8 divided by, you can just see here, it was point, okay? Now I am not writing the point, I am taking out the point. If you want to take out your point, you have to see after point how many digits I have? 1 digit, means you have to divide by 10. So 2 points I have removed, I multiply 2 or twice by 10 here. Downside also I see it is 1.6, so I remove the point from here, it becomes 16 by 10. This 10 and this 10 got cancelled here. So next step if you go, you will be getting 5 into 11 into 5 into 5 into 8 minus 6 will become 2. Downside what is left? 16, 7 and 10. 16, 7 into 10. This 10, there are 2 10 here, you will cancel 1 10. What will be left here? 5 into 11 into 5 into 5 into 10. Again you can cut by 2, 8 to the 16, 5 to the 10. If you multiply all of this, you are going to get 6 8, 7 5 divided by 8 7 the 56. If you divide, you are going to get 122.7 meter. Okay, that is approximately your length of the wire here. So our next part of the question, the same question, okay, they say that we know that in the previous part of the question they said our resistance is 10 ohm. Now they are saying that if we double the diameter, okay, the diameter is double, then what is going to be the change in the resistance? मतलब बोल रहा है कि अगर तुम्हारा diameter अगर double हो जाएगा तो तुम्हारा resistance में कैसा changes आएगा, ठीक है? So we know that R is equal to rho into L by A. From beginning we know. But in the first part of the question, they say resistance is how much here? 10. Then I wrote here 10, rho into L. Area already you know, the formula of area is your pi r square. Equation number 1 we can write. Now when diameter is double here, okay, so we got a new diameter here. New diameter is d dash is equal to 2d, means double, na? Before it was d, now it will become 2d. But again we know that we are concerned with the radius here. So I need to find out my radius. I am taking my radius as r dash. It will become what? Half of the diameter. The diameter is how much here? D dash. This is d dash by 2. D dash value is how much here? 2d. 2d divided by 2. 2 got cancelled. What is left here? R dash is equal to d here. That means new resistance. Now resistance is going to change. Okay. R dash is equal to rho into L by A. Remember here, I am not changing my length because in the question they are not saying anything about the length. They are saying about the area. So I wrote new area. Area is your A dash here. So what will be the formula for area? We know it is pi r square. Since it is A dash, we need to use the R dash value. Okay. So pi R dash whole square. Okay. R dash square here. So R dash is equal to rho into L. Pi means pi R, isn't it? You can see here R dash is equal to what? D. That means in place of R dash what I can write? D. That will become your D square. Now this is diameter, isn't it? Diameter is what? Twice of the radius, isn't it? This D was before it was D or not. That means you need to find out the diameter is nothing but the double of the radius here. So in place of D what I can write? 2R. So I can write it rho into L by pi into D. D means how much here? 2R. That means 2R whole square. That means rho into L by pi 2 to the 4 R square. That means R dash is equal to rho into L divided by 4 pi R square. I have taken out the 1 by 4 outside. What I am getting here? Rho into L by pi R square. That means R dash is equal to 1 by 4 into, you can see here, rho into L by pi R square. Rho into L by pi R square. This is equal to whom? This is equal to rho into L by A only, and rho into L by A is equal to whom? R only. So what I can write here? R dash is equal to 1 by 4 into R. You can stop your answer up to here, but that time you have to write here. That means the new resistance is going to decrease by a factor of how much? 4 here. Now if you want to write more, you can write more also. R dash is equal to 1 by 4. This is R, isn't it? R value how much you got here? R is equal to how much? 10 here. According to the first part of the question, so I put here 10. If you divide here, you are going to get how much here? 2.5 ohm. So you can like this. Therefore, the new resistance is 2.5 ohm, or you can write also that the new resistance is 1 by 4 times of the previous resistance. Okay. So that is for today. Okay. Next class we are going to discuss about the different types of connection that we can make in a wire or in a circuit. Okay, there are two types of design you can make. One is known as parallel, other one is known as series connection. Okay, and that will be discussing in our next class.